On with Unit 8, and in this video we're going to start learning Target 8B, which is all about multiplying polynomials. So by the end of this lesson you will be able to multiply a monomial and a polynomial together. You'll be able to find the greatest common factor, or GCF, of a polynomial, and we'll also learn how to factor the greatest common factor out of a polynomial. Let's look at our first two examples. They say multiply the following. In example 1, we have negative x to the third times the quantity 9x to the fourth minus 2x cubed plus 7. So for me to multiply these out, we're going to distribute. So I'm going to distribute the negative x cubed to each one of these terms. I'm going to write out that step. So I'd end up with negative x to the third times 9x to the fourth, which we will simplify in a second, plus the negative x to the third times negative 2x cubed plus negative x to the third times our 7. So when I distribute, it's just like if we were distributing a coefficient. I want to multiply that to each term. In this case though, I'm not multiplying a coefficient, I'm actually multiplying the same base here. And in Unit 7, we had all of our properties of exponents that we learned about, and we're going to apply them here. So when I have an x to the third times an x to the fourth, because the bases are the same, I can go ahead and combine those by adding the exponents. I can also multiply any coefficients that each term has. So I have a negative 1 times a 9, so I have negative 9. Then by adding my exponents together, I end up with x to the 7th power. We're going to do that same concept for each one of these. So in our second terms, I'm adding a negative 1 times a negative 2, which will give me a positive 2. My bases are the same again, so they're both x as my base, which means I add my exponents, so 3 plus 3 will give me 6. Then on my last term, I don't have any bases to combine. I can just rewrite this as a negative 7 times x to the third by multiplying the 7 and the negative 1. I can't simplify that at all because none of those are like terms since all of the exponents are different. Why don't you guys pause the video and try example 2 on your own first, and then we'll check it together. Let's check example 2. It says 5a times 3a cubed plus a squared minus 9. So I need to go ahead and distribute this 5a to every single term. So I'll end up with 5a times 3a cubed plus 5a times a squared plus 5a times negative 9. From here, if my bases are the same, which they are since everything is an a to a power, I can go ahead and add my exponents and multiply any coefficients. So 5 times 3 will give me 15, and then a times a to the third will give us a to the fourth, plus I'll end up with 5a to the third power, since I have an a to the first times an a to the second, minus 5a squared on our last term, since I have a negative 1 times the 5, and then a times a gives us a squared. I can't simplify that any further because I have no like terms, so I'm done once I distribute and simplify each individual term as much as possible. So this is going to lead us into our big concept in this unit, which is all about factoring. So factoring a polynomial actually reverses the multiplication process. So in examples 1 and 2, we multiplied these together by distributing in whatever the monomial was in front. Factoring would actually undo that. But the reason we want to make sure we know how to multiply is that reverses the process we're doing, so anytime we factor, we can actually check our answer by multiplying it back out. An important step in factoring is to first find the GCF, or the greatest common factor. And that's what we're going to focus the rest of this video on. Oops, sorry, I could not fit that there. So an important step in factoring is we always want to make sure that we find our greatest common factor first. We shorthand that by saying GCF, and that greatest common factor is what is the largest thing that every single term has in common. So in these first 3 examples here, we want to find the greatest common factor. We're not going to factor anything at all, we just want to list out, well, what would the GCF be equal to? Our first problem, we have 5x to the third plus 25x squared plus 45x. So there's two pieces that we have to worry about thinking here. I have to think about, well, what could be a number that they all have in common? So what's a factor that 5, 25, and 45 all have in common? And then in terms of the variables, I have an x cubed, an x squared, and an x. And I want to think about, well, what would the highest power of x's be that they all have in common? Let's start with the coefficient part of the number part. So I'm looking at the 5, the 25, and the 45. What number do all three of those numbers are divisible by? So our greatest common factor between 5, 25, and 45 would actually just be the number 5, because 5 is divisible by 5, 25 is divisible by 5, and 45 is also divisible by 5. I can't go any higher because 5 itself is a prime number, so it's not like I could try to divide it by 10 or by 20 or anything larger than 5. Now in terms of the x's, I'm looking at the x cubed, the x squared, and the single x to the first power. And I have to think about what is the highest power of x's that each one of them has. So when I look here, the x to the first is the lowest power out of those three, which means that x has to then be in my greatest common factor, because I know that x is divisible by x, but x squared is also, and so is x cubed. I couldn't go any higher because on this last term, I only have an x to the first power, so it wouldn't be possible for my greatest common factor to have an x squared or an x cubed, since this lowest term here is just an x to the first power. Let's look at our second example. So our second example says 3x to the fourth minus 9x cubed minus 12x squared. Again, we're going to break it apart into what do the numbers have in common, and then what do the variables have in common. Let's start with the number piece. What do you guys think the greatest common factor is between 3, -9, and -12? Our greatest common factor here is actually going to be positive 3, because both 3, 9, and 12 are all divisible by 3, and there isn't any higher number that all three of them are divisible by. In terms of our variables, we have an x to the fourth, an x cubed, and an x squared. And I have to think about, well, what would my lowest power of x's be that they all have in common? So between an x to the fourth, an x to the third, and an x squared, the highest power that they could all have in common would then be that x squared term. I can't go higher than that since x to the second is already my smallest power that I'm starting with. In our fourth example, we also had some negative signs, which we would want to factor out negatives if they all had a negative in common, because we want to kind of make our leading term there always positive. But because the 3x to the fourth is positive, then I don't need to factor out a negative. Okay, let's look at example 5. We have -2x to the fifth minus 6x cubed minus 10x squared. We have to break this part into what do all the numbers have in common, and then what do all of the variables have in common. So why don't you guys pause the video and decide what would be the greatest common factor for example 5. So in example 5, I'm going to start with our numbers. We have -2, -6, and -10. Well, all three are negative, so I'm going to have a negative sign in my greatest common factor. And then they're also all divisible by 2. So 2 is going to be part of our greatest common factor. When we look at our variable part of this, I have an x to the fifth, an x cubed, and an x squared. And the highest power that they all have in common would be that x to the second. So our greatest common factor here is going to be -2x to the second power. Okay, we're going to keep practicing this skill, but we're also going to add in this layer of factoring. So in our last examples, it says factor out the greatest common factor. So I'm going to divide this into two steps. My first step is going to be find the greatest common factor, and then we'll talk about how to actually factor that out. So why don't you guys pause the video and find the greatest common factor for example 6 first. So in example 6, we have 4x to the fifth minus 24x to the third plus 8x. When we're finding our greatest common factor, we're thinking about what numbers do all the coefficients have in common, and then about the variable part. For the coefficients, 4, 24, and 8 are all divisible by 4. So our greatest common factor for the coefficient part will be 4. In terms of the variables, we have an x to the fifth, an x cubed, and an x to the first power, which means the highest amount of x's that they all have in common is actually just x to the first. So our GCF, our greatest common factor, is going to be 4x. Now, when we go to factor out the greatest common factor, what we want to do is actually make it look like what examples 1 and 2 looked like at the beginning. So if we scroll back up to examples 1 and 2, we had this monomial in front and then all of these extra terms that were left over. If I look at all these terms in the parentheses, you'll notice that none of them have anything in common. I have a 3, a 1, and a negative 9. I have an a cubed, an a squared, and then no a's. So in this case, this is what we call factored form, because our 5a here is our greatest common factor, and that has been taken out of every single term that's left in the parentheses. So when we go to factor this, what we're going to look at is we want to have our greatest common factor on the outside, and then what's left over on the inside is the leftover stuff that didn't have anything in common. So let's go back to example 6 now and think about this. So our greatest common factor here is 4x. So I'm going to factor that out, meaning I'm actually dividing every single term by my greatest common factor. When I do that, I'm going to make sure I have enough space here, so I'm going to extend these parentheses. When I do that, I want to still have 3 terms, because I had 3 terms to begin with, so I still should have 3 places where I'm putting these into here. Let's look at our first term. We have 4x to the fifth. Now, when I factor out my greatest common factor, I'm actually dividing each term by that greatest common factor. So if I have 4x to the fifth over 4x, we know from our last unit that I can simplify this. The 4's will cancel, and x to the fifth divided by x to the first would give me an x to the fourth because I'm subtracting the exponents. So then in my factored form then, my first term here would be an x to the fourth power. Now our second term, I'm going to find by dividing our negative 24x cubed divided by our greatest common factor again. When we simplify this down, negative 24 over 4 is going to give me negative 6, and then x cubed divided by x would give me an x to the second power. So my second term here would be negative 6 x to the second. For our last term, we have our 8x divided by our greatest common factor. 8 divided by 4 is going to give me 2, and then x divided by itself is going to cancel. Or if you're thinking about subtracting the exponents, I'd have 1 minus 1, which would give me x to the 0. But remember, x to the 0 power is always going to be equal to 1, so we just end up with positive 2. This right here is what we call factored form, where our greatest common factor has been taken out of every single one of those terms. I still have 3 terms left in the parentheses, because even if I take everything out of a term, I would still have a plus 1 left. So I'll never lose the amount of terms, but I'm taking out everything they have in common. And when we're taking it out, ultimately we're dividing each term by that greatest common factor. Now we can always check this by distributing this back in. And 4x times x to the fourth would give me a 4x to the fifth. 4x times negative 6x squared would give us negative 24x to the third. And then 4x times 2 would give us our positive 8x. So it's always a good idea to check your work and make sure that you actually factored everything correctly. All right, let's look at example 7. I want you guys to pause the video and first find your greatest common factor, and then let's check that. So our greatest common factor here, we have 9x to the sixth plus 15x to the fourth plus 12x to the second. Our greatest common factor here would be each one of those 9, 15, and 12 are all divisible by 3. And then for my variables, x to the sixth, x to the fourth, and an x squared, the lowest power that they all have in common is going to be an x squared then. So my GCF will be 3x squared. Remember, when we go to factor this, I'll have my greatest common factor out in front times all the stuff that is left over. why don't you guys pause the video and decide on what is left over inside these parentheses once I factor out or divide out the 3x squared. So when I simplify this, I'm going to write this one on the side as well. So I'll have 9x to the 6th divided by my greatest common factor. I end up 9 divided by 3 gives me 3. X to the 6th over an x squared would give me x to the 4th. We'd end up with 3x to the 4th. Then plus, on our second term, we have 15x to the 4th divided by our GCF would give us 5x to the 2nd, since 15 over 3 is 5, and then x to the 4th over x to the 2nd will give me x squared. Then on our last term, we have 12x squared divided by 3x squared. 12 divided by 3 gives me 4, and then x squared over x squared cancel. So I get plus 4. And that is our factored form. Now we can always check this by distributing, which we talked about before. But another good thing to think about is if you're unsure if you had the greatest common factor right or not, what you want to look at is the stuff left inside the parentheses. And you want to make sure that they have nothing in common. So 3, 5, and 4 have no factors except for 1 in common. And then x to the 4th and x squared and a term without an x will not ever have anything in common because this last term has no x's left. Okay, why don't you guys pause the video and do example 8 on your own first, and then we'll check it together. So example 8 says negative 6x to the 4th minus 18x cubed minus 12x squared. So let's first find our greatest common factor. I have a negative 6, negative 18, and a negative 12. So I'm going to factor out a negative sign. And then 6, 18, and 12 are all divisible by 6. So I have a negative 6 and then an x squared, since that was my lowest exponent here. And both an x cubed and an x to the 4th have an x squared inside of it. When we go to factor this out, we'll have a negative 6x squared, so our GCF, then times the stuff that is left over. Now this arithmetic we've been doing on the side, I'm going to start to do in my head now. If you still want to write out on the side, go for it, but we're going to start to try to figure out, okay, how can I divide this through in my head as we get more and more practice. So for our first term, we have negative 6x to the 4th. When I divide by the negative 6, I'm just left with a 1. So I technically have a 1 there, and then an x to the 4th divided by the x squared, I would have just an x squared left. Since I started with 4 of them and I'm taking out 2 of them, I'm left with just 2 of them. And then that 1 in front we don't usually write, so I am going to go ahead and erase it. And you'll also notice because I took out my negative sign, each one of these terms is actually going to end up being positive since the negative sign was factored out. For our 18x to the 3rd, 18 divided by 6 is 3, so I'm left with a 3. I started with x to the 3rd, and I took out 2 of them, so I'm left with x to the 1st. Then on our last term, 12 divided by 6 is going to give me a 2, and then I started with x to the 2nd, and I took out both of them, so I end up with no more x's left inside on this last term. And you might be starting to notice this pattern of the fact that all of my last terms should not have any x's left over inside the parentheses, otherwise we would not have taken out our greatest common factor. Okay, let's look at example 9. Why don't you guys pause the video and try example 9 on your own first. Example 9 says 6x to the 5th minus 2x to the 4th plus 3x cubed minus 4x. So I have one more term now, but that's okay. Let's look at each piece. So on my coefficients, we have a 6, a 2, a 3, and a negative 4. None of those numbers actually have anything in common except for a 1. So far my greatest common factor isn't very exciting. If we start to look at it in terms of the variables, I have an x to the 5th, an x to the 4th, an x cubed, and then a single x to the 1st power, which means my greatest common factor is actually just going to be x. And that happens sometimes. The greatest common factor might not have a lot in it, but if it has something in it, then I want to make sure I'm factoring it out. So when I factor this out then, since I'm only factoring out a 1, the 6, the negative 2, the positive 3, and the negative 4 are actually all going to stay because I didn't factor out any other numbers. In terms of the x's, the x to the 5th if I take out one of them, I'll be left with an x to the fourth. For the x to the fourth term, if I take out one of them, I'll be left with an x to the third. Then for the x to the third term, if I take out one of them, I'll be left with an x to the second. And then on the last term, I only had an x to the first, so because I factored that out, I'm just left with the negative 4x. And again, we can always check this by distributing that x back in and multiplying it to each term, which would give me my original problem. And then I can also make sure I factored everything out by double checking that there's nothing that all four of those terms inside the parentheses has in common. Okay, our last example. And then at the bottom, there's just that reminder that talks about you can always check this by multiplying it back out, which as you're starting might be a very good idea just to make sure you're factoring correctly. Okay, why don't you guys pause the video and try example 10 on your own first. So in example 10, I have 10x cubed plus 2x squared minus 4x plus 20. So let's find our greatest common factor. Between the 10, the 2, the 4, and the 20, all of those are even numbers, so they're all divisible by 2. Now, in terms of the variables, I have an x to the third, an x squared, and an x, and then I have no x's here. So if I have a term that has no x's in it, there's no way for me to have an x in my greatest common factor. So in this example, my x here was actually, or my greatest common factor here was just actually a constant or a coefficient on here that I'm factoring out. So when I go to factor out a 2 out of each one of these, 10 divided by 2 would give me 5, and I'll still have x to the third since I'm not taking out any x's, plus 2 divided by 2 would give me 1, so I just get plus 1x squared. Then negative 4x divided by 2 would give me negative 2x. I want to make sure I have enough space. And then when I divide out 20 divided by 2 would give me positive 10. And I have my factored form. So as we can see in our last two examples, sometimes our greatest common factor either only has a number or only has a variable in it. And then in our first couple examples, we saw where we could have both a number and a variable. As you're starting out practicing how to factor, make sure you're really taking a step at a time. This extra work that we had done over here on the first two problems of dividing out each term, feel free to write that on the side if it helps you through each one of those steps, because all that factoring is technically dividing out what every single term has in common and writing that in front of the parentheses. And the reason this works is if I were to distribute it back in, I'd end up with the original problem I started with, which is always a good idea then as you're starting out that you can check your factoring by multiplying everything back out.